Hi, guys. So here are the scientific method notes for this year in case you were absent or you want to watch this again. So what we have here is our pet measurement lab table, where you're going to be recording the measurement of your growing pet every day for an entire week. Okay, do not forget to include the unit, so no naked numbers. So you need to have centimeters for length and grams for mass. And then you also need to write a hypothesis, whatever you think the pet will be by the end of the week. On the packages, it did say that they would grow 600%. So if you wanted to multiply your Monday measurements by six, you can do that, or you can try something smaller or bigger, whatever you think it's going to be. Just remember that your hypothesis doesn't have to be right. It's okay if it's wrong. It just has to be testable, right? It has to be something you can design an experiment around. And I understand if you're absent, that's probably why you're watching this video. You can get the measurements from your partner. I wanted to share this meme because it comes from a April Fool's joke where a radio DJ went on the air on April Fool's and told everybody that dihydrogen monoxide was in the pipes. Don't drink water, don't take baths, things like that. It's really dangerous, which is true. But dihydrogen monoxide is water. It's just the chemical name for water. And so, what I'm trying to show you with this meme is that we need to educate ourselves, right? That's why we're in school. That's why we're taking science, math, social studies, language arts, and all these classes, even art and everything, because it's going to make you a well-rounded individual, so that you're educated. And one of the ways that scientists learn about things is by going through the scientific method. So that's what we are talking about today. And so it's really important to educate ourselves, to look to the experts, to find out stuff that we don't know about, and to trust the people that are doing actual research, right? And research means going through the scientific method and doing experiments, not watching YouTube videos. Although there is a lot of information that you can learn from YouTube videos and you can learn from online, but it's very important that we look at the sources and find out where these people got their information and whether those are reliable, valid sources or not. Okay. And then when we do find out that it is a reliable or a valid source, we, say, okay, you're the expert, you're the one that has done research on this. So you probably know what you are talking about. Okay. So this is topic number 4 in your table of contents, scientific method. To start off with, we make observations. So we are looking at things, seeing them, hearing, taste, smell, touch, all of these things. Some things can be tasted, some things cannot, so be careful. But that is where we start off with the scientific method. Then we move on to a problem. We have to ask a question. What do we want to find out? So, for example, with the pets, we want to know how big will they grow after being in water for this number of hours, right? An entire week, every night for an entire week. Then we write a hypothesis. We educate ourselves, right? Some of you guys already knew about these little toys and what happens when you put them in water. That is an education. And we read up on it. We was like I told you, the packages say they grow 600%, right? We educate ourselves so that we can make a prediction about our question. And it doesn't matter if it's wrong. It just must be testable. I must be able to design an experiment around it. And it cannot be an opinion. For example, I can't say red roses are prettier than yellow roses because that is not testable. I cannot design an experiment. I cannot prove an opinion. Then we go to the fun part, which is the experiment. We actually carry out the tests. We do the procedure, right? We collect the data. We're filling in our table as we go along through the week. I'll talk about variables in a little bit, but it's important that the experiment be valid and be repeatable. That means that somebody else should be able to do your exact experiment and get the same results. And if they don't get the same results, then that means something's wrong, right? Somebody messed up. Either you messed up or they messed up. Something's wrong. It's not repeatable. And so that's what makes it valid. It makes it trustworthy. I told everybody in class about how I think it was like the early 2000s where somebody lied about their data and they said that vaccines caused autism and different things, and that vaccines were bad for you. And it turned out there was no data behind it. And so that caused a lot of ramifications, right? In the medical community, in the health community, because people stopped taking vaccines, and we had a resurgence of diseases like polio and measles come back because of what this guy did. And it turns out when people went back and looked at his research, they looked at his data, it turns out he wasn't being 100% honest. He had actually made up some of the data. So that's why it's really important that experiments must be repeatable and they must be valid. Then we have results. This is going to be when we basically organize our data into graphs. And so, yes, when you look at the numbers of your pets and how they're growing, you're going to be able to see that they're increasing, right? But when you look at a graph, it makes it super easy to tell that, oh, the line's going up. And you'll be able to see, like, when did my pet grow the most? Did it grow the most at the very beginning of the week, or did it kind of take a little while for it to get going and then it grew faster towards the end of the week? Or what? So graphs are going to make that very easy for us to see. Then we write our conclusion. So here we summarize our results. Just tell me in words, what happened. If the pet grew to be this many centimeters and this many grams in mass. And you talk about if your hypothesis was right or wrong, probably going to be wrong, which is okay. And then scientists will publish their results. So first, they'll share them with other scientists to get double checked, make sure that they're valid and that their conclusions are backed up by their data. And then results will be published and shared with the general public. So I wanted to point out really quick that the scientific method is not linear. In other words, it can go back and forth. Like once you have write your conclusion, you can actually go back and you can come up with another question or another hypothesis. For example, at the end of our pet measurement lab, we could say, well, I wonder if the temperature of the water makes a difference. Maybe I should try cold water. Maybe I should try hot water, things like that. So you can come up with other questions, come up with other experiments. But the important thing is not to do multiple at the same time. I have to keep the temperature of the water the same the entire week, right? I cannot change it to cold tomorrow and warm the next day because I'm not going to know what made the difference at the very end of it. You can only change one variable. So let's talk about variables. First, we have independent variables. Independent variables are the things that I change. So independent means it starts with the letter I, right? So independent means that you are changing that on purpose. If you remember in elementary, when you talked about cause and effect, this is the cause of the change. I'm putting the pets in water, so that's going to cause a change. I could also say, well, what if I want to do an experiment with plants? And I want to test out different fertilizers. I can test out fertilizer A, B, and C. The fertilizer is going to be the independent variable. It's what I am changing on purpose, right? It's going to be the cause of a change in the growth of the plants. Then the dependent variable is the effect. It's whatever is affected by what I changed. So the growth of the pets is the dependent variable because it's changing because I put them in water for more and more hours. The growth of the plant or the number of leaves that the plant has is going to change because I'm giving it different fertilizer. So it's the effect. And then it's really important that you have everything else control, right? Scientists want to be in control. That's how I remember this. You can't change anything else. Everything else has to be fair the whole week. For example, with the pets, I cannot change the temperature of the room every day. I cannot change the type of pet that you have. You have to be measuring the same pet every day. So everything else is going to remain constant. With the plant experiment, the only thing I'm changing is the fertilizers. I cannot change the amount of water that I give them. I cannot change the number of hours of sunlight that they get or anything like that because that's not fair. It's at the end of the experiment, I'm not going to know, did the fertilizer make a difference? Did the sunlight make a difference? That's why I can only change one thing at a time. Another thing is I'm going to have a fourth plant with no fertilizer, right? That way at the end of the experiment, I can say, oh, fertilizer A caused the plant to grow way more than plant D. But plant B and plant D that had no fertilizer, right, are the same. So that means that fertilizer B didn't make a difference, right? So I have that also, that comparison, which is also called a control. With the pets, we measured them on Monday with no water, right? So that way we could see where they started, what's the original, what's gonna, how is it gonna be different later on. So this is exactly what that is talking about. Notice how the mice on the left are normal. These mice were not given medicine or anything like that. And so when the scientists did give the ones on the right medicine, or who knows what they did, right? Um, they did something different to those mice. They can compare them to the normal mice, right? The control group of mice, and say, oh, these guys are kind of acting a little weird compared to the mice that did not get the experimental medicine or whatever. And then again, just to reiterate, it's really important that we do trust scientists who go through the scientific method, who know what they're talking about, who have educations in this, and who do research in this. It's really important that we trust what they have discovered. Okay. So let's talk about graphs. This is how we're going to organize our data as far as results and things. So we have line graphs. This is always going to be over time. So anytime we are talking about time, it's always going to be a line graph. For our pets, we are going to use a line graph because we're going to have the days of the week on the bottom, the x-axis, and we're going to have their growth on the y-axis. So anytime it's time, it's a line graph. Circle graphs are going to be for percentages or parts of a whole. And so this is going to be really easy to compare parts to each other and then parts to the whole. So you can say like, oh, this slice is bigger than that slice on the circle graph or the pie graph. But you can also say, oh, this is 25%, or this is, compared to the entire thing. So it's going to always be percentages with circle graphs. With bar graphs, it's amounts of something. Okay. So it's basically like I could compare like the number of people that have favorite foods or favorite desserts or things like that. So it's going to always be amounts of things. And then scatter plots are going to show a relationship between things. You'll talk more about this in math class, and also when you do eighth grade science, the HR diagram for stars. So basically, it's just a correlation of how things are related to each other. And usually there's going to be like a clump of points that are together, so you can kind of see how they're related. So what we're going to do here is you're going to have an opportunity to practice some graphing. The line graph on the left is going to have two lines, one for wolves and one for deer. And then you have a bar graph on the right-hand side. And you do need to come up with a key for both of those. Here is what you should end up with. Okay. Please make sure that you have a title, that you label your axis, and that you connect the dots on the line graph. On the right hand side, you have two different bars, and so they're different colors, so it makes it nice and organized. Here's an example of a circle graph and a scatter plot graph, which we're not going to practice in class, but I did want you to take a look at them. Okay, so here, go ahead and work on your graph. And if you have any questions, please let me know. Thanks.